Hello everyone, welcome to Electronically Connected. So in this video, we will be discussing about subtractors. We will be discussing the construction of a half subtractor and also be focusing on the construction of a full subtractor. So let's get started. So let's start with a half subtractor. So before that, let's quickly revise how to subtract two binary numbers. So let's take for example, if you want to subtract 1 0 with 0 1. Now 0 minus 1 is not possible. So we borrow the 1 from the left hand side and put the 1 on top of the 0. So 1 0 in binary, 1 0 in binary is basically 2. So 1 0 becomes 2. So 2 minus 1 is 1. So 1 0 that is 2 minus 1 is 1. And because we borrowed the 1 from here, so what is remaining is 0 and 0 minus 0 is 0. So we have our answer. Now this answer is called the difference, that is difference D, and we borrowed a 1, so it's called borrow. So with the help of this, let us again revise how to do a truth table of the half adder. So we have two numbers A and B, which will give you a difference and the borrow. Two numbers, four combinations. So 0 0, 0 1, 1 0 and 1 1. 0 minus 0 is straightforward, so 0 and 0. Now 0 minus 1, we have seen right over here, the answer is 1 and a borrow is also 1. 1 minus 0 is straightforward, 1 and 0. 1 minus 1 is 0 and the borrow is 0 as well. So there we have it. So just like a half adder, we can see that our half subtractor is a box. We can call this a half subtractor box. So HS with two inputs A and B and two outputs difference and borrow. Let us see what are the equations of our difference and borrow. Here we can see D is 0 1 1 0, which is a representation of our XOR gate. So we have A XOR B, which is a difference equation, and the borrow is 0 1 1 0, that is 1 is present at A is equal to 0, B is equal to 1. So that means A bar B. This is our equation of difference and the borrow for a half subtractor. Now let us see how to convert our equations to the half adder circuit. So we have two inputs. Let's draw them A and B. We have an XOR gate for the difference. So we have an XOR gate which is connected to A and this is connected to B, which is going to give me my difference. Next we have our borrow, and the borrow you can see we have A bar and B. So that means we need a NOT gate from A. So we have a NOT gate and A dot B, right? So we have and gate right over here connecting our A bar and B, which is going to give me my borrow. And there we have it. So we can see that the half subtractor is just like a half adder with the truth table, its equation and the circuit diagram for its construction. Now let us understand the construction and the logic behind the full subtractor. If you remember how to construct a full adder, then the construction of a full subtractor is very easy. So let's see. Just as in a full adder, we have our full subtractor block which has the inputs A and B, and we have another input which is the borrow in. Just how we had the carry in full adder, we have a borrow in full subtractor. Here we have a difference D and then we have a B out, the same as we had a C out. So this is our full subtractor. Let us see the truth table of a full subtractor first. So we have three inputs A, B and B in and two outputs D, that is a difference, and borrow out. So three inputs, 8 combinations. So very first we have 0 minus 0 minus 0. So it's 0 and 0. 0 0 1, we have 1 and 0. Then we have 1 and 1. 0 and 0. 1 1. 0 0. 0 1 and 1 1. So the equations of a full subtractor is pretty much similar to the equations of a full adder. So let us see here. So we have D is equal to 0, 1, 1, 0. So we have, it's going to follow the same order. So we have A XOR B, and the whole thing is XORed with B in. And in similar fashion, the B out is A bar B plus A XNOR with B, and we have B in. So let us see the construction of our full subtractor using the gates. So we have three inputs, A, B and B in. We have A XOR B, so we have first the XOR gate. We have A and B, and which is XORed with B in. So we have another XOR gate whose output is going to be the difference equation, and the other input of this XOR gate is going to be B in. Now let us see the construction of the equation for B out. So we have first is A bar B. So basically we have A bar B, which is ANDed together. And then we have A and B XNOR together along with B in, which is another AND gate. We have this from here, and the whole thing is OR together. And there we have it. This is our B out. Now, if you will identify, we can see that this part of the circuit and this part of the circuit next is repeating. And also we can identify in the just before this topic we were talking about half subtractor. We can see that this circuit, and if you can identify, we can see that we discussed half subtractor just before this topic, and we can see that this circuit, the XOR gate, NOT gate and the AND gate makes a half subtractor. So we can replace this with a block of half subtractor, and this block as well with a half subtractor, and let's call this half subtractor 1 and half subtractor 2. And we can still have our inputs A and B, and we can see this half subtractor is connected to the next one. So we have this connection, and then we have our third input, which is the borrow in, which gets connected to a half subtractor, giving out the first output, which is the difference. And next we have for the B out, so we can see that there is a wire coming out from here and the wire coming out from this AND gate, which is OR together. So in a similar fashion, we have one output and the next output, which is OR together, giving out our B out. So just as we saw the construction of a full adder using two half adders, similarly we can construct a full subtractor using two half subtractors. So with this we come to the end of our video. In the next video we'll be discussing how to construct a 4-bit parallel adder, what is advantages and disadvantages, and what's the construction of it. So thank you for learning. See you next time. Till then, happy learning.